Understanding the basics of lighting. So, what is lighting? If you take a look at dictionary.com, what they describe is the act of enlightening or illuminating, the arrangement of lights to achieve particular effects, the science, theory, or method of achieving particular effects by the use of lights, the way light falls upon a face, object, etc., especially in a picture. So I'd say for what we're talking about, number four is probably the most relevant. We're going to be talking mainly about how lights fall upon different surfaces and how they react to those different surfaces and how we perceive them. So the main idea is, so there's some things that I want to talk about that I think are pretty important. So lighting is this thing that illuminates our world. I think we all understand that. Light is a form of energy that travels in waves, and when that energy hits the surface, it bounces off and hits our retina. Our retina turns that energy into electrical signals that travel to our brains. The brain turns those signals into the images that we see. So I just think it's actually a fascinating process that it is this form of energy, and we perceive the world that way through these signals that we get. I was going to tell you about the probably most basic way that we can describe a lighting setup and how that looks appealing for us. And I think this is the base setup that you can do to make things look professional. And when we talk about this is going to be a 3-point lighting setup. But with that 3-point lighting setup, we should get something that looks similar to this image that you see here. It should produce something on an object, and if we take something like a sphere, you're going to get this thing that is considered core shading. So you can see this this darkening effect as the surface turns away from that light source, it starts to move into darkness. But in most cases, we are going to get some light, some of that energy that we're talking about, and it bounces off the surface. It could be walls, it could be the floor, but you can see this is going to produce bounce light for us in here. This is the shadow side. This is our cast shadow. So for whatever our main shadow casting light is, then we should get a clear, easy to read shadow direction from that. And with those visual cues, we should know where that main light source is from the shadow information. So we've got our highlight side, and then the specular highlight tells us something about what that surface type is. So if you don't see much of a tight highlight at all, if it's really broad, if we think about a PBR system, physically based rendering, and if you think about the metal rough system, if we had a material that is not metallic, and so that's a value of 0, and we take a look at roughness, and something like glass is a value of 0 for roughness, and on going all the way up to 1 is full roughness, it looks like the sphere is probably somewhere like 0.7 or 0.8. There's not much of a highlight at all, and it might probably be maybe even higher, maybe 0.8, somewhere in that range. So if we go even lower, we can start to see a tighter highlight to form on here in this area. And so this is a quick illustration that I put together that maybe emphasizes this 3-point lighting and tries to be just a little bit more heavy-handed with that example on here. So we've got a main light, shadow casting light. This could be our key light, and then from there, that lighting direction should produce a shadow on the floor or whatever that surface is that this thing is sitting by or on. And so again, there should be a very clear shadow direction from there. And on the opposite side of that main light, you're going to get some type of bounce light that you see on here. And then another lighting thing that you could do is put a light that produces a rim along the edge of that object that you see there. These are some a setup that I gave to the students of mine last cohort, and this is what I feel is what's needed to show off your models as maybe a 3D model, or at least the base setup that you would have for this. So you'd have your model, and again, this is just using a 3-point lighting setup where there is a main shadow casting light, and that could be an area light, it could be a spotlight. It's up to you to choose what that thing is. I tend to usually do this very similar setup where my light is coming from the upper right of the object, and I'm trying to get most of my highlights to fall in this area that you see here, and you can see it falling pretty much in this particular area. We do have some of that core shading going off to the left over here, like that, and there should be some core shading here. And then off to the left somewhere is a blue point light that I'm using for rim on there. Now the bounce light is happening because this was rendered in Maya Arnold. It doesn't necessarily mean that you need to render in a program like that, but with this one it does global illumination within the program. And we can also use a thing called image-based lighting. So with image-based lighting, we're able to take a photograph of the world, and it's got a low and a high exposure range, and we can use that for lighting information. And so that's actually pulled in there, and it's illuminating some of the object and making it to where it's not going into pure darks in there. So again, I think this is the base setup that you would need to show off your work in a professional way. Okay, another main idea. Lighting direction has an effect on mood. So simply changing the lighting direction and intensity can have a big impact on mood. So I did put together some examples of this, of some head topology that I had, and produced a more faceted look so you could see a little bit of the planes on the face and how those values and the lighting, how it falls across there and how it changes depending on the lighting that you have. So this is the same lighting setup that we just looked at with the previous renders. This is all done in real time in Maya. So the quality is not quite as good, but you can see this is just a pretty vanilla lighting setup for this. So it feels to me like this is something that you might want to use in a product shot or something like that to show off the dimensionality of something and try to do it in somewhat of a professional way. If you do a lighting direction, and this is more of a frontal lighting direction, and so I'm finding some examples of this, some things from film, and I keep talking about this as something that you can do. It's called the squint test. So if you squint your eyes at an image, it can take away a lot of the smaller details and the finer details and help you focus in on the bigger shapes and then maybe areas of contrast. So if you squint your eyes in this one, I do tend to look at this area in the face, and another area that I think is a high area of contrast on here is the teeth really stick out. Something that I think is pretty interesting is that you can tell that they've put a really strong light source off to the left and to the right, and it's produced this really strong rim on both the left and the right of the character's face. Something else that I think that they did that was pretty interesting in this image, as you can see, there's a shadow that falls down right and through this area. So it does tend to make you look in this particular area of the face and get you to focus. So that's something else that I think that as artists, that's something that we're going to be striving for in our images that we produce. You're going to want the audience to look in a particular area on your image. And so that is a way that we can funnel lighting into a particular spot and make us focus in there for that. So here's another lighting direction, and this one's from the bottom. And I think you've probably seen this quite a bit in different horror films and things like that, where they're trying to produce this appearance of discomfort or something that's evil, something that's scary, right? And so here's another image that does have some similarities to what we were talking about. There is a strong rim light, at least back and behind the character, enough to where you can see it's picking up rim light on these parts of the fingers, but then it's also producing a nice strong rim on this part. So even though that this face goes really deep into shadow here, this still stands out as a shape because of the amount of rim that's on here. And I do get the appearance that there is some light that is happening more so from the bottom, and you can tell that by the highlights on the face and the shadows. So this area goes dark, this gets a little bit lighter here, and as it goes across the surface, it starts to get darker in through here. So there is a much stronger light at the bottom of this character's face, and definitely produces an area effect. So this lighting direction from the top feels heroic to me, and that's because I'm really fond of an artist called Alex Ross, and the work of Alex Ross, I do tend to see this as a lighting direction that is used on faces quite a bit. Another artist that I'm a big fan of is Jim Lee, And Jim Lee, his work, he also uses a very similar lighting setup. I think his is at times maybe a little bit more pronounced because his is a very hardcore comic book look that's got very stark lights and darks just because of the penciling going to the inking process. But I do tend to see this as a lighting setup where the lighting is above and produces like this darker area underneath the eyes and underneath the nose. And so when I see that, because I've seen that so many times in comic books, I just tend to think of superheroes or heroic figures. So the other thing I did with this image, I just took the saturation of it and desaturated it. Because if you look into the work of Alex Ross, something that I've found about his work is that he likes to take photographs of his subjects and set up the lights for that, and that becomes his reference for whenever he paints. And I think another part of his process is that there's times that he will work in grayscale and black and white and then add the color information over the top of it. So in the previous section, we just looked at value and contrast. And it is possible that you can work in black and white and figure out your value and contrast first and then add the color information over the top of it. So that is completely, totally a valid way of working. Okay, something else that I want to talk about, global illumination. So I took this from the documentation on unity3d.com, and you can see what they wrote. Global illumination, GI, is a system that models how light is bounced off a surface onto other surfaces, indirect light. Rather than being limited to just the light that hits a surface directly from a light source, direct light, modeling indirect lighting also allows for effects that make the virtual world seem more realistic and connected, since objects affect each other's appearance. One classic example is color bleeding, where, for example, sunlight hitting a red sofa will cause red light to be bounced onto the wall behind it. Another is when sunlight hits the floor at the opening of a cave and bounces around inside, so the inner parts of the cave are illuminated too. So if you've ever seen these type of images, these are set up to really drive home what is really happening with global illumination here. So we've got a room here, and we've got a red and a green on these sides, and as the lighting is pulled into here, the energy that we were talking about at the very beginning from that light will actually bounce off this wall, hit the floor, and then bounce up into the sphere. And you can see that that light is carried through with that energy and actually pulls onto these shapes that you see here. And on this side, we are getting a green, and it's coming from over here. And the same thing for this sphere. If you take a look at this, obviously it's very, very green here, but we still are picking up red from over here from the bounce from this red wall hitting the floor and then hitting back up on the surface. You can even see hints of red down here on the floor, and you can definitely see greens in the shadows in this area, reds here, and there's even some green in this shadow area right in through here too. So here's another example, and this is in UE5 in Lumen. And it's a very similar test, some different shapes, and you can see they've got some different material types on here and how the different material types will affect this as well. I do think that it's probably easiest to see that color differentiation whenever you've got something that's supposed to be close to a pure white, and that shows off the color really well. So this type of setup shows these examples, I think, fairly well. So in the architectural world, the imagery that's starting to be produced with real-time engines is just getting to be pretty amazing. I don't think this example is probably the best example as far as the light bleed thing, but there is another thing I wanted to talk to you about in the CG world, and that is ambient occlusion. And I think these renders have some really nice examples of what ambient occlusion can do for your scene. And if you take a look around in the real world, you can see that in corners and things like that, it's hard for light to actually escape that and to bounce off. It gets trapped like in these corners. So it produces this darkening effect, and it really helps punch out the shapes that we see in the world. So another idea about this ambient occlusion. So ambient occlusion is a scalar value recorded at every surface point indicating the average amount of self-occlusion occurring at the point of the surface. It measures the extent to which a location on the surface is obscured from surrounding light sources. It is used to approximate self-shadowing and adds realism to lighting by mimicking the effects of indirect light sources such as sky, ground, walls, and so on. And so maybe a test that you can do is if you took your hands together, and if you put your hands all the way together, you could probably see some type of darkening effect as the two hands meet together, and you just start to pull that away. You can see that light go away. Other things you could do is get solid glasses or things like that, put it on the surface of the table, and just watch what happens as it gets really close to the table and sits on the table, and if you take your hand and you lift that up. So that's something that you could do for yourself in the real world to take an example and to see that in action. So here's an example that I just found online, and this is, I thought was pretty interesting. This is just rendered with ambient occlusion, and just having the effect of this shown on here gives us all the information that we need from a shape standpoint to say what is going on in this world. So we don't even need a directional light to clue us in to what's going on shape-wise. Just the contact shading between objects and how close they sit together is enough to describe the world. So I always just find these renders pretty interesting. So you can see here's what it looks like fully lit and fully rendered at that point. So taking that concept on, I am starting to notice people in the digital world who are digital painters taking that same mindset for what is happening in 3D rendering and applying that to two-dimensional drawings. So you can see here off to the left we have a sketch, and then we have the combination of AO and then also shadow together. And then that becomes the basis, like what I was saying before about Alex Ross. If you're able to paint in a way that you're painting purely in black and white and you're figuring out value, you can add color over the top of that, and it produces a very realistic shading model that ends up feeling like you're looking at a 3D rendered model. So here's another example from this artist, David. And you can see the sketch, you can see the shadow pass that's been put together, you can see what was created for AO, and then combining that AO and shadow together, and then putting AO and shadow and color, and then doing final lighting and putting highlights and gradients and color gradients on there. So again, it produces a really highly three-dimensional look to it, and it does feel like it emulates what happens in the computer whenever the computer renders these things out.